Okay. So this is 4.5 course division, and then I'm gonna post 5.1, 5.2. Or no, first I'll post 4.5, then the tops for 4.5, then 5.1, 5. Let me just cut to the chase. We have curve sketching. Okay, curve sketching. These three questions I'm pretty sure will take me at least 7 minutes each. Curve sketching follows a lot of steps, so I'm not gonna waste any time, and I'm gonna chop chop. Okay. Do I think this will come in your written? Yes and no at the same time, if that makes sense. Okay, so I have this over here. You want to sketch a curve. It has a few steps. Okay, the first thing you're gonna do when I say sketch the curve, that means you're gonna draw the curve. I mean, just so you guys can better understand what I'm gonna do. To draw the curve, there are many things you need to look at. Okay, first thing, to sketch any curve, you don't need to have every set of points. And يعني here مثلا you can like try points, so you can just say 1 is this and 2 is this, 3 is this. This is أيام زمان, right? But realize how now I'm saying sketch. Sketch means I don't really care about the numbers, but there are certain things on your graph that I'm going to care about. Those certain things are like asymptotes, stationary points, x-intercepts, y-intercepts. These are the things that your corrector is going to look at. Also, he's going to look at whether your graph is going up or going down. Also, he's going to look at whether your graph is going concave up or concave down. Concave down would be like this. Hold up, would be like this. You see, if it's going up like this or going up like this is concave up, this is concave down. You check concavity, you check your stationary points, you check. In general, we have 5 things. Okay. Also, he's gonna check whether your function is it as it approaches positive infinity is it going up, or as it approaches positive infinity is it going down. Okay, these are the things that every corrector is going to be looking at, and these are the things that are in the marking scheme. So without further ado, let me start. Let me chop chop. Okay, the first thing we're going to study when sketching the curve, we need to find out some things. The first thing you'll always find out is the behavior. Okay, I need to know, as I go to the right, is my function going up, or as I go to the right, is my function going down? Same thing, as I go to the left, is my function going up, or as I go to the left, is my function going down? Okay, these are the things we need to look at. And what do we mean by that? Behavior. So how do we check the behavior of a graph? We say as x approaches positive infinity, what does y approach? And as x approaches negative infinity, what does y approach? How do we check? You always look at, I can't write. Can I not write here? It's not nothing right on it. Okay, like this. So how do you check the behavior? You always substitute infinity into your highest power, highest degree term. So let's substitute أول شيء positive infinity to the power of 4. So we're gonna get, since it's an even power, obviously you're gonna get y approaches positive infinity. Okay? And what will y approach as it approaches negative infinity? 3 times negative infinity to the power of 4. Since it's an even power, even if it's negative, it's gonna end up being positive. So that means my graph is gonna approach positive infinity here and positive infinity here. So on both sides, it's gonna be going up as you move to the end. So this is your first thing. The next thing I'm gonna look at is my graph decreasing or is it increasing? Or sometimes it might be increasing at the start, but later on it might be decreasing. To study whether your graph is increasing or decreasing, we say behavior of y prime. You guys know, if y prime is positive, then my function is increasing, right? Because y prime represents the slope. If the slope is positive, then we're going up. How about if y prime is negative, then we're going down, right? Because the slope would be negative, you're going down. So how about y prime is equal to 0? What would this represent? A stationary point. And this is one of the things that your corrector is going to look for. So when I say behavior of y prime, that means I'm studying 3 cases. I'm studying, one is y prime positive, one is y prime negative, and one is y prime equal to 0. And akid, without to do all of these, I first need to find y prime. So let's find what is my y prime, guys. Y is equal to 3x to the power of 4 minus 4x to the power of 3. Sorry, 4x to the power of 3. How do you derive this? Everyone knows how to derive. Exponent times coefficient reduced by 1. exponent times coefficient reduced by 1. So this is y prime. Let's see. When is, I'm always going to start by saying, when is y prime equal to 0? Okay? Because when you find your root, you can then do table of variation, like this. You can do the table of variation. You guys know the table of variation. So an x, f prime of x, and then you can do like this, and you can put negative infinity, positive infinity, and then you can study the sign, right? So first, to do that, you always need your root, okay? Find your root, find your stationary point, okay? Find your stationary point. You need to find your stationary point. Because that stationary point, when you're graphing, you're going to have to draw, you have to write a circle on it, okay? And that would be a stationary point. So if I get 2 comma, I don't know, 4, or 2 comma 4 as my stationary point, you have to write here, okay? And you guys know the stationary point, it will be must increasing, and it will change to decreasing, okay? You need the stationary point. Okay, let me continue solving. After I get everything, I'll show you why we need everything. Y prime equals 0, that means 12x cubed minus 12x squared is equal to 0. And if you solve this equation, factor out 12x squared, you're going to get x minus 1 equals 0. So you're going to get two solutions, x is equal to 0 and x is equal to 1. So these are both what, guys? Stationary points. And obviously, guys, when I graph, do I just say, can I say I graph x equals 0? No, x equals 0 is a line. It's a point, right? So I need to know how much is my y at x equals 0, because I need the point. I need the y values at both these x coordinates so I can actually graph the point, right? Okay, so x equals 0, how much would y be? Substitute it into your original y. It would be 3 times 0 to the power 4 minus 4 times 0 to the power of 3, which is 0. So that means 0, comma 0 is a stationary point. Make your work organized. Stationary point. And then x equals 1. Let's substitute x equals 1. 3 times 1 to the power 4 minus 4 times 1 to the power of 3 is equal to what? This is 3 minus 4, x equal to minus 1. That means 0, comma minus, 1, comma minus 1 is also a stationary point. Okay, so I like to always put a box around the things that I will use later on. Okay, so this is useful over here. This is useful over here. Okay. These up here are okay, they're useful. They're obvious. So we now know our roots. I need to know when is y prime increasing, when is it decreasing. Okay. How do you do that, guys? We always said do the table of variation. Okay. Do this x and f prime of x. If you can want to say y prime, that's completely fine. You start at negative infinity, you go end at positive infinity. What are my roots? 0 and 1. So 0 and 1 at f prime at 0 and 1 is equal to 0. Let's see. Some people say, oh, in between the roots it's the same sign as this, then before and after the roots it's no. Why can't you see that? Because, guys, this is not a quadratic. You actually have to do it yourself. How do you do it? You always test the point. And you're going to need this, guys, later on, because we're going to start later on. You're going to do this table of variation maybe for degree 5. Okay. So learn always, unless it's a quadratic, then you can know before, in between the roots, it's opposite to the sign of the quadratic, and before and after the roots, it's the same sign as the quadratic. But here it's not quadratic, so what we're going to do, we're going to try a point before 0. A point before 0 would be negative 1. Okay, negative 1, let's see. Negative 1 substituted into y or y prime? Y prime, because I'm checking the sign of y prime, right? So let's try negative 1. When you substitute negative 1, this is my derivative, right? 12 negative 1 to the power of 3 minus 12 negative 1 to the power of 2. Okay. Actually, you know what? I'm recording here. Instead of substituting it into this, I'm going to substitute it into the factor 1 because it's going to make my life easier. Okay, substitute it into this one here because this is way easier to solve, right? Than this. So, I'm going to substitute in this. This is the same thing as this. We just factor out 12x squared. So, I'm going to substitute 12 negative 1 squared times negative 1 minus 1. Why I'm doing this is I'll show you now. 12 times negative 1 squared is positive. But negative 1 minus 1 is negative. Positive negative gets you what? Negative, right? Positive times negative is negative. That means here it's going to be negative. Okay? Try a point in between 0 and 1. You can try مثلا 0.5. Okay? But I will give you a trick. Okay? And they teach this in university, but I'll tell you from now. If you have negative here, you can't have negative here. So it's going to be positive. Because this is a stationary point, right? So that means if it's going down here, it's going to change. So it's going to go back up. Since this is a stationary point, so if it's going up here, what's going to happen here? It's going to go down. Okay? You can use this. It's completely fine. However, there's only one exception to this case. That is when you have a repeated root. Okay? A repeated root let's say مثلا you have this. Okay, you'd have 2 repeated twice. Okay, that you won't see this at our level. You'll see this later in calculus. But for now, to make your life easier, if it's negative here, that means positive here. That means after it's negative. It's always alternating. So we can conclude, right? We can conclude what? That our function, or we can say y prime. Let's say y prime. Once it's positive, it's greater than 0 between, or no, don't never say between. Let's be professional. Let's write it in math terms. For what? X in between 0 and 1. صح? So between 0 and 1. Y prime is negative for X less than 0, right? Everything to the left of 0. And X to the right of 1, so greater than 1. Okay? So we can put a box around this because we're going to use this later. Okay. So far we did this. So we can kind of start to see a graph now. Okay, like we said, 0, 0, we have 0, 0, and we have 1 minus 1, so that will be here. And we said it's increasing between 0 and 1, so... Okay. So I was just checking something now, because obviously it won't be, it will have to decrease, but and I have it as increasing. So I made a mistake over here. I told you the trick here, it applies for all cases except for when you have repeated root. And my dumbass didn't see that 0 is a repeated root because we said x squared, right? X squared. So that means 0 is a repeated root. Okay, so for that case, this won't apply. It will apply, but you have to change something. If something's a repeated root, basically it means you just repeat the sign. Okay, so if it was negative, you repeat it, and then here it would go to positive. Okay, so if I were to go back to my table of sign just to repeat what I did earlier, okay, you can try a point between 0 and 1 and get 0.5, and it's going to be negative. Okay, but here's what you do. I told you that if it's negative here, it's always going to be positive here, unless 0 is a repeated root. But it's a repeated root because you have x squared. If I say x squared equals 0, that means I have 2 zeros. Okay, so since it's repeated root, basically what it means, repeat your sign. Repeated root and repeated sign. So negative and repeat it again. Basala, is 0 repeated 3 times? No. So that means I only repeat the sign twice. And I go, now I switch to positive. So that means, let me change it here. I wrote this one wrong over here. Y prime now would be greater than 0. When's it positive? For x greater than 1, right? For x greater than 1. And then y prime would be negative for, when's it negative? X less than 1, right? So, if I kind of now, I can box this up, right? I kind of now have an idea of my graph. I know 0, 0, and 1 minus 1. And I know in between 0, 0, and 1 minus 1, it's going to be decreasing, right? Because when does it start increasing? Only after 1. So only if this is 1 here, it only starts increasing after 1. So here it would be decreasing. So even you can see on the graphing calculator, you see this part here, I have it as decrease. So we're kind of having a graph. And we know it was decreasing before, so it would kind of look like this and continue to decrease. And then after 1, it continued to increase. So this is roughly how the graph is going to look like, yeah? But here's the thing. You never know if, masalan, it was decreasing like this, or if it was decreasing like this. These are two separate things. This is concavity. So that's the next step. We need to know if it's going to be concave up. Well, this is concave up, because concave up is like this, okay? Or if it's going to be concave down. This is concave down, okay? You have to check this. So now to check concavity, how do you check concavity? You need to check y double prime. So the third step would be now what? The behavior of y double prime. You know, when is it concave up? When y double prime is greater than 0. When is it concave down? When y double prime is less than 0. Okay, so behavior of y double prime. We need to know when it's positive, when it's negative. And we also need to know what happens when y double prime is equal to 0, guys. Remember, this means inflection point, right? And that's when concavity changes. So first, Like I did over here with table of variation, I'm also going to do another table of variation, but for y double prime. Okay, how do you do it? Same exact thing. Find your root. Oh, let me know what is y double prime. I need to derive y prime again. We said y prime is this, right? Let's derive it again. 3 times 12 is 36. Sorry, let me write y double prime equal to 36 x squared minus 24. This is y double prime. Okay, now I can find when is y double prime equal to 0. I can find my inflection point. Okay, so equate it to 0. You're going to get 36x squared minus 24x equals 0. You can factor out 12x outside. You're going to get 3x minus 2 equals 0. So you're going to get two solutions. You're going to get x equals 0. In this case, 0 is not a repeated root because it's not x squared, it's x. Okay, and then 3x minus 2, that means x would be equal to 2 over 3. Okay, so we now found our two inflection points. We found our roots. Can I now do the table of variations to know when it's greater than 0 and when it's positive, less than 0? Yes. So again, x f double prime of x, right? You can say y double prime, it's fine. We start from negative infinity and we go to positive infinity. I just want to add that here, the table of variation I draw now will be slightly different to when I have asymptotes. When I have asymptotes, it's going to look a bit different. When we get there, I'll explain. Here you have x equals 0 as your root and 2 over 3 as your root. Same rule that I did earlier. Test a point before 0. We could say negative 1, right? Let's substitute negative 1. 12 times negative 1. I'll do it down over here. Let's substitute negative 1. It's before 0, right? So 12 times minus 1 times 3 times minus 1 minus 2. This will be negative. 3 times minus 1 minus 2 will also be negative. Negative times negative, that means our answer will be positive. So this here will be positive. That means after 0 will be what? It always alternates, right? Negative. And then after 2 over 3, it alternates again, so it's going to be positive. So this is my table of variation. So I now know that x equals 0 is an inflection point, x equals 2 over 3 are both inflection points. Type. You need to know also the y coordinate, right? You can't just say x equals 2 over 3. So to find our y coordinate at x equals 0, x equals 2 over 3, again, what do? We substitute it into our original equation. For x equals 0, we already found 0, 0, right? So we're going to say 0, 0 is an inflection point. And it's also, we said it's a stationary point. But is it a stationary point? X equals 0. No, it's not a stationary point. You know, I didn't correct this earlier. 0, 0 is not a stationary point because it was decreasing before 0 and it continued to decrease. So we can just say 0, 0 is a saddle point, right? You guys remember what saddle points are, right? It's when y prime equals 0, but it doesn't change its sign. Okay, so I should have not written this. Sorry, I didn't correct it. I should have mentioned it earlier. When I corrected here, I didn't correct this. 0, 0 is a saddle point. Okay, you can't say it's a stationary point if it's negative, negative. 0, 0 is an inflection point here. And also we need to know 2 over 3. How much is y at 2 over 3? So you go back, 2 over 3, comma what? We go back and substitute 2 over 3 to our original equation. 3 times 2 over 3 to the power of 4 minus 4 times 2 over 3 to the power of 3. I'm just going to do this in a calculator. 3 times 2 over 3 to the power of 4 minus, what was it? 4 times 2 over 3 to the power of 3 minus 4 times 2 over 3 to the power of 3. You get minus 16 over 27. Minus 16 over 27 is also an inflection point. So we can now put a box around this. طيب. We now know our inflection points. I'm going to erase this part here. I don't want. Our whole point of this was know when it's concave up, when it's concave down. When is it concave up? We can say y prime, double prime is greater than 0. When is it greater than 0? Before 0, right? So to the left and 0. For x less than 0. And for after 2 over 3. And x greater than 2 over 3. When's it negative? y prime is negative, double prime is negative between 0 and 2 over 3. For x between 2 over 3 and 0. Okay? So we can also put a box around this. Walid, are we done? Almost. We have one more step. Okay? So we found our behavior of y prime, behavior of y double prime. The last step is now what we call the x and y intercepts. Okay? X and y intercepts. X and y intercept. The x and y intercept. The x intercept is when the graph cuts the x-axis. And in that case, what happens? Y is equal to 0. How do you find the x-intercept? Y equals 0. So you take the original y, which is 3x to the power 4, right? Minus 4x cubed. We equate it to 0. How would you solve this? Factor out x cubed. You would have 3x minus 4 equals 0. You get 2x equals, you get a 2x intercept. X equals 0. And x is equal to 4 over 3. Okay? So we have 2x intercept. And we go at the x-intercept, y always equals 0. So you're going to have a point 0, 0, which we already said earlier. And 4 over 3, 0 are both x-intercepts. Now, the y-intercept. The y-intercept, I'm going to actually draw it on this one here. The y-intercept is when you cut the y-axis. And at here, what's the value of x? X equals 0. Well, also, we already found it. It's 0, 0. But to find it, I'm just going to show you. To find the y-intercept, I'm going to label this x-intercept. And then here, y-intercept. To find the y-intercept, x equals 0 at the y-intercept. So you go to your original y, 3x4 minus 4x cubed, substitute 0. And you get 0. That means 0, 0 is y-intercept. If you get this in your exam, 0, 0, it's both an x-intercept and a y-intercept. And without wasting time, know that this is your y-intercept as well. Because a function can only have one y-intercept. You will never see a function looking like this. Okay, you'll never see something like this. What's this? This isn't a function. Remember, for one value in the domain, you can have two values in the range. But for one value in the range, you can only have one value in the domain. Basically, you can only have one y-intercept in any function. So, we now found x-intercepts, y-intercept. And I forgot one thing before I finally graph it. It's one step. Nobody really pays attention to it, but you have to write it. Okay? It's your domain of definition, df. Okay? It's called df. Basically, if you have any excluded values, you have to write it. In this case, is there anything that's excluded? I don't have any asymptotes because there's no fraction. Okay? So for that reason, my df, domain of definition, okay, basically means what x values are excluded. Are there any restrictions? Here, there's no restrictions, so you just say r with a line beside it. This means all real numbers. Okay? Write it like this. df is r. Okay, so this is a lot, but this is everything you need. So now can I start my graph? Yes. To start your graph, you will be given graphing paper. You'll never be given just white paper, blank paper. So they might ask you not to do the order I gave you. They might start with x and y intercept, and then they might start with find the stationary points and the inflection points, and then finally study the behavior. They might just ask it as a part A, B, C question, and study the behavior of this, and then find the y prime, and then this, and they might not even ask you to graph. But here, I'm doing the whole question because you must be prepared for anything. So here's what you do when you want to solve this question. You did the previous steps. You now graph your y-axis with a ruler, of course, and your x-axis. Okay, this must be done with a ruler. You're gonna put a nice label over here. Hatilla x, on hatilla y. Okay, you can put the arrows only here and here. You don't have to put them everywhere. But let's see now. You now need a scale. Okay, you'll always in graphing paper you'll be given these grids. Okay, I like to use for every grid one scale. Okay, let's see. Here I have. If it's just whole numbers, you can easily just do 1, 2, right? But over here, I'm gonna use 1 over 3 as my scale. Why? Because I have over 3s. Okay, And over 3s are annoying to work with. So if you use your scale as 1 over 3, like if this is 1 over 3, 2 over 3, this would be what? 1. So I can easily graph 4 over 3 because I know to just be over here. This would be 4 over 3. So everybody has their own preference. This isn't something that you lose marks for, but it's something that I find easier to use when graphing, okay? Since I have over 3, I'm going to use 1 over 3 as my scale. So if I use 1 over 3 as my scale, that means every 3 boxes is 1. So this would be 1. This would be over here 2. And this would be over here 3. And this would be 4. 1, 2, 1, 2, 3. 1, 2, 3. Okay, and so on and so forth. Okay. Okay. Now going up, my scale for the y-axis. Going up, do I have over 3s? No. But I do have over here, I have over 27, but I'm not going to use 1 over 27 as my scale because I'm going to need 27 boxes for 1. So that would just be stupid, okay? So Anna, personally, I'm just going to use minus 16 over 27. I think how much is that as an actual decimal value? So it's between, you could say 0.6. So I think I'll just use a normal 1-to-1 scale. Or actually, no, I'll just use 2. I'll use 2 for each one. Okay? True 2. Yeah. Everything I just said now about the scale is your personal preference. You don't have to do what I'm doing. Okay? طيب. This is now when you start graphing. Always start with graphing your points. Okay, I forgot to go down here. Huh? It's 2, minus 3, minus 4, minus 5. Okay. So, start by listing your points. What do I have here? I'm going to read through all the boxes. This is why I told you box them up because you're going to have a lot of writing. 0, 0 is one of my first points. So I'm going to go to 0, 0, and I'm going to put a circle. Okay? Circle your points like this. Other people put an X. I guess that's completely fine, yani. But I prefer to use circles. Okay, 1 minus 1. So we're going to go to 1 minus 1. Put a circle around it. Okay, we're going to go to, let's see, what else do we have? We have 4 over 3 comma 0. So 4 over 3 comma 0. Where is 4 over 3? 4 over 3 is 1.333. So why did I use 1 over 3 as a scale? So this is 1. This would be 1 over 3, which is 4 over 3. So this here would be 4 over 3. So my point, 4 over 3 comma 0, would be this one over here. I have 2 over 3 minus 16 over 27. 2 over 3 minus 16 over 27. 2 over 3 is over here. Minus 16 over 27, I told you, is minus 0. Is 16 over 27 is almost 0.6. It doesn't have to be exact, so you can just put it over here. This is around 0.6. After 0.5, because this is 1, as this is 0, 0.51. So about after 0.5, over here. Okay. So we now have all our points. Some people here, they're going to be confused. They're going to be like, oh, what I do now? Okay. So when you have your points, you're going to connect them. Okay. Obviously, we're not going to connect them just like this. That's obviously wrong, right? We're going to be curved. Here, it's obvious that I'm going to be going down, right? It's kind of obvious. Let me see here. When would I... Oh, I forgot about... Did I put 1 minus 1? Yeah, okay. When am I going up? I'm going up for after 1, right? We don't care about that. Obviously, we're going up. To go from here to here, you have to go up. I'm going down for excess of 1. So, before 1, I'm going to be going down. So, before 0, even here, before 0, I'm going to be going down. Okay? We're going to be going down. So, let's see. How is my concavity going to look? Am I be going concave down? Or am I going to be going concave up? Okay? Let's see. This is the first thing. To connect, obviously, we're going down, but you need to know in what sense. Are you going to be going concave down or concave up? We know that it's concave up before 0 and after 2 over 3. So after 2 over 3, it's concave up. Once it's concave down for between 0 and 2 over 3. If it helps, concave down, draw it. This is concave down. And concave up is like this. It's just a U. These are parabolas, okay? Concave down between 0 and 2 over 3. And also, I'm starting between 0 and 2 over 3. So in between here is going to be concave down. So how am I going to be going down? I'm going to be going down like this. You see the second part? It's going down like this. So that means between 0 and 2 over 3, I'm going to go down like this. Okay. After 2 over 3, what happens? We said what? After 2 over 3, it's concave up. So it's going to be going up. Sorry, it's going to go down. How? We're continuing to go down, right? I didn't connect this. Okay. We're continuing to go down. Am I going to continue like this? No. Why? Because we said 2 over 3 is an inflection point, so it changes concavity. And even here we said after 2 over 3, it's concave up. So now when I'm going to go down, I'm going to go down like this. These are two different things. You see how it's going down here? And you see how it's going down here? These two are both going down, but you see how here it starts like this, but here it goes steep and then goes like this. Okay? Here now we're going concave up. So it's going to go like this, the second one. Okay? So it's going to be like this. Okay. Let's see. Is there any change in inflection? I'm going to go up now. Is there any change in inflection? No. We said in general, it's going to continue concave up as long as it's after 2 over 3. So we're going to continue concave up. And again, concave up. Going up when it's concave up, you see how it goes. It goes up like this, straight. Okay? So it goes up straight. So it's going to go like this. Now this would be, of course, yani, and I'm using a computer, so try, yani, it will kind of look weird, but yeah, erase this part at the end. So this will be how your graph looks. Okay, it's continuing up. طيب. Some people will say, why didn't it go down? Because remember we said, as you go, we don't have any points here to confirm that it went down, right? Command we said, the first thing we said is, as you continue to positive infinity, y also continues to positive infinity. So y will continue going up as you go to the right. Okay, let's see now, how before 0. Can we finish our graph like this? No, we have to actually like, what comes before 0? Are we going to be going down? Are we going to be going up? Let's see. Before 0, we said, let's see, before 0 is before 1, right? And we said y is less than 0 for everything before 1. So everything before 1 would be decreasing. طيب, we're going to be decreasing. اتفقنا. I don't mind. But am I going to be decreasing concave down or concave up? Let's see. We said before 0 and after 2 over 3, it's what? Positive. So it's concave up. Concave up. How do we decrease concave up? It looks like this. I drew it here. It looks like this. You see the U? It's going to be going down like this. So that means you don't really need any point, but instead of starting from the left and going like this, which is completely right, by the way, I'm going to start at 0 and go like this. So this would be my graph. Of course, it's kind of weird, but yeah. How many minutes for that? 32 minutes for one question. Damn. Okay, so in your exam, I explained, so I took a lot of time. In your exam, you start behavior. You start first thing you write domain of definition. Okay, start your domain. Then your behavior. Okay, check for any asymptotes. Okay, check for any asymptotes. That's with the behavior. You'll see later. Behavior of y prime. Always behavior of y prime. Fast, solve. You don't need to do what I did. And I explained, so I took time. List your saddle points, your stationary points. List when it's positive, list when it's negative. Then, behavior of y double prime. Again, list your inflection points and study the behavior. Positive, negative, positive. When is it positive, negative, positive? List your inflection points and list when it's positive, list when it's negative. Yani concave up, concave down. Then, your last part, x and y intercepts. The x-intercept is when y equals 0, and your y-intercept is when x equals 0. And then finally, graph. Okay, let's see. I put it into Desmos, so we can kind of see how our graph looks. So this is, obviously, I'll keep zooming out, and it continues to go up, because we said that as you go to positive infinity, it continues to go up. So this is kind of how it looks. Let's kind of compare. So you can see here, it goes down, goes to 0. You see the concavity? You see the concavity, how it is? Over here, it was concave down, no? You see? Concave down. Then it switched over here and became concave up, you see? And continued concave up and increasing. Like we did over here. Of course, I should have you can do this if you want to continue it. But there's no need. This will get you the full mark. Okay? That's question 1. Question 2, I'm going to go way faster than what I did now because I was explaining in question 1. Here, I'm obviously going to explain, but I'm going to go a bit faster. So, we remember our steps. First thing is your domain. Let's see. Since our domain here, we have a fraction, we need to see our excluded value. Okay, so before writing domain, see, do you have any excluded values? Yes. We know that 2x minus 1 denominator cannot be equal to 0. That means x cannot be equal to half. So when you write your domain and you have an excluded value, this is how you write it. Your df is are, it's all real numbers except your excluded value. Okay, it's always all real numbers minus set notation 1/2, your excluded value, always. Okay, other people write it like this, is minus infinity, comma, your excluded value, and they write it, I think, wait, yeah, so they would write it like this, union, and then they would do like this, show my half, comma, positive infinity. Okay, so basically what this means is this, the graph, it continues, but over here at half, it skips it. That's what this bracket over here means. Square bracket means it's included. Parentheses means it's not included. This is not something you need to know, but I always prefer to write, because you're gonna use this later in university. And I always prefer to write r minus half. That means all real numbers except half. Okay, let me continue. Behavior now. Check. We said x equals half is an excluded value. What does that mean? That means x equals half is my vertical asymptote. I don't need to write that. X equals 1/2 is the vertical asymptote. Now check for horizontal asymptotes. How would you check for horizontal asymptotes? You always take x is infinity. Since here it's power 1, here it's power 2, you're gonna have, if you take x as infinity, you're gonna have two, you're gonna have, sorry, infinity over 2 times infinity. Okay, and you're gonna, in squared, huh? Wait, they cancel. Okay, yeah, there's no square. So you're gonna have infinity over 2 times infinity. They cancel, so you're gonna get half. So that means your horizontal asymptote, sorry, y equals 1/2 is your horizontal asymptote, right? When there's this, remember, when there's the same power, that means your horizontal asymptote is always the coefficient over the coefficient. This was one of the rules. But again, I don't like using rules. Okay, anyway, so that means as x approaches positive infinity, y, what does it approach? It approaches half. And also as x approaches negative infinity, y, what does it approach? Half. Okay, that's what the horizontal asymptote means. You're gonna need all of this. So we're gonna put the box around this, all of this. We're gonna put a box around this, and we're gonna continue. Okay, now behavior of y prime. Let's find y prime. If y is equal to x minus 3 over 2x minus 1. Okay. How do you find y prime? How would you derive this? Using the quotient rule, right? What's the quotient rule? It's u prime v minus v prime u over v squared. So here is going to be u prime v, so 1 times v, 2x minus 1, minus v prime u. What's the derivative of this? 2. U is x minus 3 over v squared, which is 2x minus 1 squared. So you're going to get 2x minus 1 minus 2x plus 6, because I just distributed the negative 2, over 2x minus 1 squared. You don't need to expand the denominator. Just you're going to cancel these two. You're going to get minus 1 plus 6. You're going to get 5 over 2x minus 1 squared. This is y prime. Okay, now you know y prime. How would we how would we continue from here? You know, to find the behavior of y prime, you always check your root when it's equal to 0, and then we see when it's positive, when it's negative by table of variation. So let's see here. 5 over 2x minus 1 squared. When is it equal to 0? Let's see. When you have a fraction equal to 0, that means its numerator must be equal to 0. Always. Or if you don't believe me, just cross multiply, and you're going to get 5 is equal to 0. Okay. Can 5 ever be equal to 0? No. That means here, no roots. What's the sign of 5 over 2x minus 1 squared? 5 is positive. And since it's squared, this is positive, because you know squared means it's positive. That means the function f of x, the derivative is always what? That means the derivative y prime is always what? Positive. For something to go from positive to negative, it has to cross 0. So if there's no roots, that means it always stays as the same sign. And the sign here, 5 is positive, 2x minus 1 squared is positive. That means y prime is always greater than 0. Always. Okay, what does this mean? We have no stationary points and we have an increasing function all the time. Okay. Okay, we finished from y prime. Let's continue to y double prime. This is to check concavity. Now, to derive this again, it would kind of be, actually, you can derive this again. 5 over 2x minus 1, y prime is equal to 5 over 2x minus 1 squared. How would you derive this? You have to take 2x minus 1 squared up. Don't use the quotient rule because we don't have x up. So how would it be? Let's continue simplifying this. We're rewriting it as this. We make the power negative when you take it up. How do you derive this? We're going to use the chain rule, right? So 5, derivative of the inside, derivative of the outside, which is, we're multiplying, fuck. Okay, you take the 5, you always put it on the side. Remember the coefficient, you put it on the side, just multiply it then. 2x minus 1 to the power of minus 2. How do you derive this? Derivative of the outside, always, chain rule. Derivative of the outside, minus 2 times 2x minus 1. Reduce the power by 1. Multiplied by the power, the derivative of the inside, which is 2. And when you multiply these, 5 times 2 times 2, you get minus 20. And this is negative power. That means over 2x minus 1 to the power of 3. So this is y double prime. Let's see. Y double prime. Let's study the sign of it. أول شيء, to study the sign, you see when does it equal 0. That means minus 20 over 2x minus 1 cube equals 0. And like I told you, for a fraction to be equal to 0, then the numerator has to be equal to 0. If you don't believe me, cross multiply. And you're going to get minus 20 is equal to 0. And you know this is false. That means y double prime has no root. That means it always stays as the same sign. So y double prime is always what? Let's see. Negative 20, it's negative. Now here, 2x minus 1 cube, it can either be positive, it can either be negative. Okay? It can either be negative or positive. You need to know when is it negative, when is it positive. 2x minus 1, when is it negative? Let's see, it's negative for x less than half. And when is it positive? When x is greater than half. So, we know if it's negative also, that means the function would be positive. So, remember we took this last year, a over b, right? For x and the sign of the fraction. It's always negative divided by, you don't actually, no, sorry. You don't write it like this. X, and then you say numerator, and then you say denominator. We took this last year. Okay. X, and then we say numerator over denominator. Okay. X, we have half, and we have half, right? That's our turning point over here. Before half, the numerator is always negative. Negative. But at half, before half, how much is our denominator? It's also negative because it's less than 0. After half, it's positive. So you can see here, before half, how much will the sign of the fraction be? Positive. After half, what will the sign of the fraction be? Negative over positive, negative. So, and then at half, it's excluded because remember it's an asymptote. It's one of our excluded values, right over here. It can't be equal to half. So, when is y prime greater than 0? It's greater than 0 for x. When is it positive? For x before half, right? For x less than half. And y prime is less than 0 for x after half. Many teachers skip this step when explaining. I despise it. I hate it. I hate it so much because it doesn't make sense. How do you explain like this? You can't explain like this. You can't explain. My teacher, for example, he just drew that. He drew it like this. And he said, oh, it's increasing here, it's increasing here. Then he's like, concavity, عادي, you'll figure it out yourself. Just put the function into a calculator, you figure it out. That's not math. This isn't math. I'm sorry, but you need to know concavities. So we now know the sign of our function. We know when it's positive, concave up, when it's negative. Okay, let's see here. Now our x-intercept, y-intercept. X-intercept, I'm going to put a box around this, huh? Our x-intercept and y-intercept. This is our last part. Our x-intercept is when the function equals to 0. What's my original function? X minus 3 over 2x minus 1. Okay, x minus 3 over 2x minus 1. We know that for it to be equal to 0, the numerator has to be equal to 0. So x minus 3 equals 0. That means x equals 3 is the x-intercept. What does that mean? 3, comma, 0. Okay. Y-intercept, this is x-intercept. The y-intercept is when x equals 0. So you're just going to substitute x equals 0. So 0 minus 3 over 2 times 0 minus 1 equals 0. So you're going to get negative 3 over 1. So it's going to be negative 3. So 0 minus 3 is the is the y-intercept. Now we can graph. Let's graph. We don't have any fractions over here. We have maybe 1 over 2. So I'm just going to use 2 spaces for everyone. Okay, so again, I'm gonna cut to the part where I drew the scale. Okay, this is how the graph is gonna end up looking like, but I'm gonna cut. So I think I cut. Yeah. So I drew. Oh, I forgot over here. I don't think. Yeah, it's relevant actually. Yeah, minus 2, minus 3, minus 4, and خلاص, the rest doesn't matter. Let's see, what do we have a box around. We're gonna start by our asymptotes. You always draw your asymptotes. Half and half. X equals half is a vertical line. Okay, don't make the same mistake I did in IG math where I drew x equals half as a vertical line, as a horizontal line. So x equals half is a vertical line. You must show, if it comes in your exam, you must show, let me zoom in a bit, the asymptotes. Okay, and the asymptotes are always drawn by horizontal lines. So I'm gonna draw it. I'm gonna draw it in red just so you can see it better. Okay, you must draw it as, sorry, a dotted line. Okay, that's always your asymptote. It's in a dotted line. Let me cut to when I finish drawing this. Okay, I'm done. And beside it, you put x equals half. Okay, how about our horizontal asymptote? We said it's y equals half. Okay, so we're going to go to y equals half, and we're also going to put the same thing. So let me cut to that. And I drew it now, and I'm going to, am I recording? Yeah, okay. I'm going to put beside it y is equal to half. So these are my asymptotes. What does this mean? It means my graph cannot cross these values, okay, whatsoever. Let's see now. What do we have? Do we have any stationary points? Not really. We don't really have much to work with other than the x and y intercept. We have 3, 0 and 0 minus 3. Okay, 0 minus 3. So we have a point over here. Sorry, I just realized it's not 0 minus 3 because 2 times 0 minus 1 is minus 1. I don't know how I put that, as it should be positive 3. So over here, it's not 0 comma minus 3. Let me undo. Fix this over here. 2 times 0 minus 1 is negative 1. So minus 0 of minus 1 is positive 3. Okay. So over here, I'm going to put 0 comma positive 3. Okay. I'll continue using black because it's a bit more realistic. Okay. Now, our other point, it was 3, 0. So over here, 3, 0. I want you to understand, when you have an asymptote like this, to the right, horizontal and vertical, before the asymptote, you're going to have a graph in one quadrant. And after the asymptote, you're going to have the graph in another quadrant. You'll never see something like this. Never. Because like I told you, you can't have the same y value for one x. Okay? You can't have it. So you're always going to have a graph either going like this, or maybe going like this, or maybe going from up to down. Something like this. You get what I mean? They will always be like this. Sometimes you might have this also. Okay? So let's graph it. Let's see, what do we have? We know that y is always increasing. Okay? It's always increasing. With asymptotes, you're going to ask yourself here, we're always increasing, right? So I'm going to start on the left. I'm not going to graph on the right first. I'm going to start on the left. We said y prime is greater than 0 always. That means my function is always going up. So you're going to ask yourself, am I going to start below the asymptote or above the asymptote? You should know, keep in mind that you can't cross it. I know I'm going to increase. If I start below the asymptote, if I start over here below the asymptote, you either start over here or over here. You can't start over here. Why? you always start at the asymptote. What? Not exactly on the asymptote, because that's wrong. But I'm saying any around it. Why, by the way? Why am I doing this? Because the asymptote, the definition of an asymptote is basically inta as you go to the left, what value of y are you approaching? We said the value of y that you approach, that's actually what the asymptote is. And we found that to be half. That's why the horizontal asymptote's half. That means inta on the left, you're going to start over here at half. Okay, so you're starting at half. You're going to increase. So akid, are you going to go like this? No, that's wrong because you're crossing, right? So we're going to start above and we're going to go up. How are we going to increase? Am I going to increase like this or am I going to increase like this? We have to check the concavity. The concavity, we found it to be concave up for x less than half. So everything before x half, it's concave up. What does concave up look like? This is concave up. So that means if you look at how we're increasing, we're going up like this. Okay, so we're going to go up like this. It doesn't have to be at any specific point. As long as you show it doesn't cross the asymptote, but it just approaches it, starts increasing. It crosses the y-axis, but it just doesn't cross the vertical asymptote. Let me make this a bit better. This is very bad. It should be a bit, should be a bit curved. Oh, it's not curved. 1 second. Okay, so just the same thing over here, but this part cannot cross the asymptote. It can't cross it, okay? طيب. Now, after, we know also we're going to increase. And like I told you, you always start at the horizontal asymptote. You can't start over here. لا. You need to start over here at the horizontal asymptote. Sorry. In between, over here on the left, you go to the asymptote. And on the right, you should also be approaching the asymptote. So over here, you can't start at the asymptote because when I go to the right, I should be approaching it. Again, remember that the asymptotes, you only reach the asymptotes when you go to the left and on the right. But in the middle, there's no, you don't start at it. Okay, you should know at x equals half, always at the vertical asymptote, you're either starting from up all the way at infinity or starting at negative infinity. You're either starting at one of them. Why? Because you guys know that this x equals half. If you substitute it, you're going to get infinity. Why? If I substitute x equals half, 2 times half minus 1, you're going to get 0 as your denominator, and you know that would get you infinity. So, okay, you're going to ask yourself, do I go from positive infinity or negative infinity? This is where the question comes. Remember, are we increasing or decreasing? We're increasing. طيب, if I'm increasing, how do I start from positive infinity and continue to increase? I can't, right? So I'm going to start over here at negative infinity, and I'm going to start to increase. How am I going to increase? I'm going to increase concave up or concave down. Let's see. We know that we're concave down for everything after half. So everything after half, it's concave down. That means, what does concave down look like? It looks like this. That means when I increase, I'm going to go like this. So over here, I'm going to increase. Make sure you start near the asymptote. Okay, not touching it, but very close to it. Okay, and you go up and continue to go up. And again, come very close to asymptote. Guys, your graphs shouldn't look like mine. It should be a bit curved and not slanted like this. But don't worry, your correctors will not really care if you have some jagged parts, because we're humans, guys, we're not robots. You're not expected to have a perfectly smooth graph. Okay, so don't waste your time erasing and writing and erasing. Anything that looks kind of curved, man, عادي, it's fine. Okay, so just like that, you're gonna get this graph over here, and you can see over here in Desmos how it looks. Okay, let me use this part because this is the part I care about, the curved parts more. Okay, you can see it started from half, kind of like from half. See, as you go to the right, it approaches half. As you go to the left, what does it approach? Half, but it never crosses it. Okay, وكمان at the vertical asymptote, look at the vertical asymptote, it's infinity. It goes up over here, like over here. If I were to continue until the vertical asymptote, it will continue going up until infinity. That is the definition of vertical asymptote. The vertical asymptote is when y equals infinity. Okay, that's why we say, because you can't graph infinity. Okay, so over here this should continue going up, and over here this should start like from down. Okay, this isn't the same for every graph. Sometimes it might go down to infinity. Okay, so to revise what I did, start with your domain of definition. Okay, your domain definition, you find it by checking which are my excluded x values. Okay, when you find it, you put r minus whatever it is as a set. Also, you have your excluded x value will be your vertical asymptote. Then horizontal asymptote, you all know how to find the horizontal asymptote. Just plug x infinity, and you're gonna get half in this case. Okay, so y equals half is my horizontal asymptote. طيب, you're gonna study now your behavior of y prime. Over here, why I wrote this command, I should have mentioned this, but this is basically just to show you, whoa, as you approach positive infinity, you get half, and as you approach negative infinity, you get half. Okay? Then you study your behavior of y prime. You derive it like I did here and check your sign. In this case, since it was positive over positive, that means y prime is always positive. In this case, then you find your behavior of y double prime. And I found my y double prime to be like this. It would be way easier if you're just working with power 2, because power 2 would mean it's always positive. But in this case, it's power 3. So you actually have to check when is it positive, when is your denominator positive, when is your denominator negative. In this case, if my denominator is positive, that means negative over positive, that means my final answer would be negative. You see? And if my denominator was negative, that means negative over negative would get me my final answer as positive. It would help if you put it in a table like this. Um, this is just the way I was taught last year. Okay. So that means you would get when your fraction is positive, that means y double prime is positive for when I am before half. And then it would y double prime would be negative for everything after half. Okay. That means it would be concave up before half, concave down before, as the concave down after half. Then your x and y intercepts. You know how to find them. X intercepts when y equals 0, y intercepts when x equals 0. And then you just graph. Question 3. In my opinion, I see this one coming more than these two. Because these two have asymptotes. Maybe if she would give you a way easier one than the one I just solved. And the one I solved is kind of easy, Sarah, compared to the one I'm going to do now. The one I'm going to do now is hard, Sarah. Because you have, it's not hard, there's oblique asymptotes. So you walk in, you see this on your written part. The first thing you do, I told you, is check for asymptotes. In the last question, I only checked for horizontal and vertical, but I should have also checked for oblique. When you have an oblique asymptote, you can never have oblique and horizontal together. But in this case, I have oblique y because the power here is greater than the power here by 1, and that means I have oblique asymptotes. The first thing I'm going to start, obviously, is I always start with my vertical because this is the stuff you can get done easily. Vertical asymptote, that means your denominator cannot be equal to 0. That means x equals 2 is the vertical asymptote. Okay? These questions, you would get the hang of them, but they need time. Really, they need time. Do I think they'll come written? I'm not going to tell you no, because, and usually I would think no, but all math teachers were sent an email regarding telling their students to make sure to get pencil to the final. That's just what I heard. I'm not gonna tell you any false information. I know my job here is to explain and equal khara. Okay, so I'm explaining here. Whether you choose to study it or not, that's your choice. But I'm explaining it. If you want to study, you can watch my video. X equals 2 is the vertical asymptote. Okay, that means okay. You found your x. So now I can write my domain of definition. You always write after your vertical asymptote, you write your df. It's always r minus curly bracket your excluded value. طيب. After you found your domain of definition, you check for your other asymptote, for horizontal or oblique. In this case, it's oblique because power of the numerator is greater than the power of the denominator by 1. How do you find your oblique asymptote? How do you find it? You divide your numerator by your denominator. And like I told you, I like to use synthetic division. Synthetic division, x minus 2. How do you use synthetic division? You write your root, x minus 2. Then you list your coefficients. 1, minus 1, minus 3. Drag the 1 down, multiply by 2. Minus 1 plus 2, 1. 1 times 2, 2. Minus 3 plus 2, minus 1. So your new coefficients, it was squared, so now it's going to be reduced to power 1. So this is going to be 1x, and what would be after it? Just the coefficient as the constant term. And then this one over here would always be the remainder. So plus remainder, negative 1. Okay? طيب. I always ignore the remainder. You never care about the remainder in oblique asymptotes. You care about this part. So that means x plus 1 is the oblique asymptote. And you guys know x plus 1 isn't a horizontal vertical line. It's an oblique line. It's a line that goes like this. Okay? Actually, to be specific, it goes like this. Okay. Anyway, we found our domain definition. We found the asymptotes. What do you do? Behavior of y prime. Let me go up a bit. Behavior of y prime. This one's a bit annoying because you have degree 2, and to derive that, it's a bit hard. Derivative of the numerator. Always it's u prime v minus v prime u over v squared. U prime v, 2x minus 1. That's u prime. Times v, which is x minus 2. Minus v prime u. V prime is x minus 2, so the derivative would just be 1. U would be the numerator. x squared minus x minus 3 over x v squared, so x minus 2 squared. So you're gonna get 2x minus 1 times x, 2x squared, 2x times minus 2 minus 4x, minus 1 times x, minus 1 times minus 2 plus 2, minus x squared. You distribute the minus, huh? Distribute the minus inside. Ignore the 1, because who cares about the 1? Plus x plus 3 all over x minus 2 squared. So we're going to simplify this now. 2x squared minus x squared will get you x squared. Minus 4x minus x is minus 5x. Minus 5x plus x is minus 4x. 2 plus 3 is 5 over x minus 2 squared. So this is y prime. How do you study the sign of y prime? You check when is it equal to 0. When is it equal to 0? When the denominator equals to 0. When the numerator equals 0. I'm tweaking. When the numerator equals to 0, right? So when is it equal to 0? When x squared minus 4x plus 5 is equal to 0. Is it ever equal to 0? It's a quadratic, so you need to check, are you able to use the quadratic formula on it? Always no. If you want to know if a quadratic equals 0, you check the discriminant. Discriminant b squared minus 4ac. If it's negative, if delta is negative, that means there's no roots and it's never equal to 0. Let's see. B squared, you would say delta is equal to b squared minus 4ac, right? And in this case, it's going to be equal to minus 4 squared minus 4 times 5 times 1. And in this case, you're going to get 16 minus 2, which you're going to get negative 4, which is less than 0. Okay? Let me actually write less than properly. Minus 4, which is less than 0. That means x squared minus 4x plus 5, it's always what? What's the sign of x squared? It's positive. So that means the sign of the quadratic is always positive. That means x squared minus 4x plus 5 is always positive. That means here, the sign of y prime, how's it going to be if it's positive over squared? What does squared mean? Positive. So that means y prime is always greater than 0. Type. The next step is concavity, y double prime, right? Let me write this a bit better. So I want to check the solution. Well, actually, the solutions here, they're not even wasting their time. They only found y double prime for the first one. After the last one, they didn't even find y double prime. They just took concave, they took it to be concave up here, and they took it here to be concave down. And now, honestly, it does make sense if you do graph it, okay, and you want to increase, right? If I increase concave up, it would look like this. I have an asymptote here. So if it looks like this, it's going to cross the asymptote. So for that reason, it's instead of going like this, in the last question, I'm saying, it would obviously go like this. And then over here, remember you start from negative because you're increasing. If I increase like this, come on, it will cross the asymptote over here, and we don't want that. So obviously it would kind of like increase, ignore this part over here, it would increase like this, okay? So I'm seeing, because now if I find y double prime, it's going to be way too long, okay? I found y double prime because I saw a discussion in my class. It was, to get y double prime, it took me maybe 7 lines, okay? It's a lot of solving if you want to derive this again. So I'm not even going to waste time. I'm just going to graph from now. I'll find the x and y intercepts. I'll skip the y double prime part. If you see this in your exam on tomorrow or Monday, whenever you're watching this, skip y double prime, okay? But for the easy ones, like the previous page over here, you need to find y double prime here. This is very easy, okay? Let's see. Let's find the x and y intercept, and then khalas we graph. X intercept, y intercept. X intercept in this case would be y equals 0. My original was x squared minus x minus 3 over x minus 2. When does it equal 0? When x squared minus 2, x squared minus x minus 3 equals 0. When the numerator equals 0, right? Type. You can factor this. You can factor this. You can get 3 and 1, because 3 times 1 is 3, and 3 minus, no, actually, that's wrong. Sorry, don't forget about that. You'll get, yeah, I can't really think of anything. Anyway, you need to find the discriminant. Yeah, I think I cut off. I had to get something. But x squared minus x minus 3 equals 0. You use quadratic formula. You'll use minus b plus minus root b squared minus 4ac over 2a. Delta b squared minus 4ac would be minus 1 squared minus 4 times 1 times minus 3. You can get 1 plus 12, which is 13. Okay, so you're going to get minus b, so minus minus 1 plus minus root 13 over 2. So 1 plus minus root 13 over 2, on calculator, 1, start with plus root 13 over 2, you get 2.3. So let's just write it as 2.3, and the second one as minus 1.3. Minus 1, let me just check. Yeah, so yeah. So you get these two values, and then for the y-intercept, you substitute x as 0. So it'll be 0 minus 3 over 0 minus 2. Negative, negative. So the answer is going to be positive. So it's going to be 1.5. Okay, 3 over 2 is 1.5. Comma 0. Sorry, sure, is 1.5. That means the y-intercept is 0, comma 1.5. Okay, so we now have our 2 points. I'm going to write 2.3, comma 0 over here. And I'm going to write minus 1.3, comma 0 over here. I don't see anything else other than the oblique asymptote and vertical asymptote. Okay, I guess we can start graphing. Remember, I skipped concavity, and I'll show you what to do with concavity. Let me cut to where I drew the axis and the asymptote, okay? Okay, so I drew the x and y axis. I drew the, oh, I swapped these, sorry. This should be x plus 2 over here. And this would be, sure, as the, shit, this is x equals 2, the vertical asymptote. And this over here is the oblique asymptote, y is equal to x plus 1. So, some people, okay, oh, I can select them. Oh, oh, that's cool. Okay, so x equals 2, I drew it here on. Y equals x plus 1, I also drew it. Y equals x plus 1, some people don't know, they're in grade 11, they don't know how to graph a straight line. You take any 2 points and you just connect them. Y is equal to x plus 1, I took 0, comma 1 and 1, comma 2, because if you substitute 1, you get 2. 1 plus 1 is 2. So I took 0 because 0 plus 1 is 1, so 0, comma 1. And I took 1 because 1 plus 1 is 2, so 1, comma 2. These 2 points, I connected them. Okay, so these are your 2 asymptotes. Let's see, we don't really have much points other than 2.3, comma 0. So 2.3, comma 0 is over here. 2.3, comma 0. And we have minus 1.3, comma 0, which is over here. It's actually right over here. Okay, so it's beside the asymptote. We also have 0, comma 1.5. So over here. So we need to see y prime. We know that y prime is always positive, so we're always going up. Okay, like I told you, when you start to the left you start on the asymptote. So you would go along the asymptote and you would increase. Whoa, sorry. It should be like this. Hold up. You increase. طب, in this case, I increased concave up. Some people would say, why didn't you go concave down? Because now we didn't find y double prime. If you go concave down, you're going to go like this. In this case, did I stay along the asymptote? No. And you're supposed to stay along the asymptote. Okay? So you have to stay like this. Hold up. There you go. Type. How about here? You can't have up and down, right? So we're going to go all the way here. We know we're still increasing, right? We're still increasing. We're still going to increase. And remember, when you swap from quadrant to quadrant, you always start either at positive infinity or negative infinity. Since we're increasing, can we increase starting from positive infinity? No, we're going to increase starting from negative infinity. So we're going to go down. We're going to increase. Remember, when you increase, you can't just go like this. Okay? If you go like this, type, okay. If you go like this, what's going to happen? You're going to cut the asymptote up here. You're not allowed. So what are we going to do? Are we going to increase concave upwards? No, we're going to increase concave down. Why? Because I'm going to increase in a way where I don't cut the asymptote. And there is a mark for this. Why am I erasing? Because I should end very close to the asymptote. Like this. See how here it's close and here it's close. So this is how our graph looks. Actually, let me zoom in. This is how it looks. And you can see here, this is how it looks. Okay. So see, this is all they did. Yani, okay. They obviously didn't show the steps for deriving. What's 1 plus x plus 1? Oh, they solved a different way. Okay. Yeah, okay. You obviously, yani, okay, I guess, yani, okay, you can do what they did. Here, what they did is, when we divided and we found the oblique asymptote, they basically put that as, they put it on the side and they put the remainder as -1. When you put the remainder, that means -1 over the original value x minus 2. So what they did is they took out the x plus 1 and they put it as like this. I guess you can, and they derived x plus 1 by itself, derived this by itself, which is the same thing as what we did, by the way. Yeah, adi. And then they said in the y prime is always positive, which, by the way, if you do this, you'll get this wrong. Okay, you're not allowed. You have to show why. You have to show everything you just did. Okay, like you can't just say like this. You have to show how you divide it. You can either use long division or the way I did, by the way. So here we're done. This is it for curve sketching. Do I continue doing? How many questions are there? Oh, there are multiple. Okay, I'll just do them. Okay, which of the following is true about the sense of variation in here? Okay, when is it increasing, when is it decreasing? So we want to look at y prime. What's y prime equal to? Minus 12x. Just minus 12x. Okay. How do you know when it's increasing, decreasing? You always find your stationary point. So you always equate it to 0 to find your root. That means minus 12x is equal to 0 and gives you one solution, x equals 0. طيب, let's draw the table of variation. Okay, minus infinity plus infinity. Your root is 0, so here it's 0. Before it, let's see, negative slope. That means the line is going down. So if you were to draw this is how I think about it, by the way. Before it crosses 0, it was positive, and after it crosses 0, it's negative. You can also do it the old-fashioned way that we always used to do, and this one is, you can't go wrong with this one. It's substitute a point before 0. A point before 0, -1. -12 times -1, you get positive 12. That means here it's positive. And you always alternate. Well, why did I put 12? I meant to write positive. And you always alternate. So if it was positive here it would be negative. Okay? Type. So when is it increasing? It's for increasing for all values of x before 0. So it's increasing for all values of x before 0. And when is it decreasing for all values of x after 0? Decreasing for all values of x after 0. Yeah, I guess, that's it. That's all they're asking. So let's see, 2, 3. That'd be correct. 2, 3. Type. Question 24. Obviously, you don't have to do everything I did. Minus 12x. So I just write the table of variation. Function 4x cubed plus x to the power 4. Okay, when is it increase and decrease? So we want to study the behavior. And when we study the behavior, you only look at the highest power. So x power 4. We want to see. Oh wait, no. They're saying increase and decrease. Sorry, why did I say behavior? Increase and decrease, and command we study y prime. In this case, y prime is going to be equal to 12x squared plus 4x cubed. Right? Type. When is it increasing? When is it decreasing? When is y prime increasing? You always find first when is it equal to 0. If 12x squared plus 4x cubed equal to 0, what would be x? Factor out 4x squared. You can solve. You're going to get 1. Sorry. Yo, oh. You're going to get 1. 1. 12 divided by 4 is 3. 3 plus 4 divided by 4, x equals 0. So you get two solutions. You get x equals 0 as a repeated root. I'm going to put repeated beside it. And you're going to get x equals minus 3. So you're going to go x and then y. Or, sorry, x and y prime. I'm going to put negative infinity, positive infinity. What are my roots? Minus 3, 0. We know it's 0 at that value. Let's see. Before minus 3, let's try a point. Let's try minus 4. Minus 4. Here you have 4x squared. What? No, sorry. Try a point minus 4 and see the sign. Let's try minus 4. It'll be 4 times minus 4 squared times 3 minus 4, right? 3 plus minus 4, whatever. This is going to be positive, obviously. This is going to be what? Negative. Positive, negative gets you what? Negative. Since, okay, yeah. Is minus 3 my repeated root? No. So it's going to alternate. Negative is going to become positive. Is 0 my repeated root? Yes. That means this positive is going to repeat itself. Positive. And there's no other root for it to alternate. So it's going to be negative, positive, positive. So when is it, without looking here, when is it decreasing? It's decreasing for x less than minus 3. And when is it increasing for x after minus 3? So it's increasing on the intervals minus 3 plus infinity. When I say minus 3 plus infinity, it means everything after minus 3. So x greater than minus 3. No. Oh, no, it is. But increasing for everything after minus 3. Right? So yes, this is correct. It's increasing on the interval 0 plus infinity only. Although it's correct, you're also missing this minus 3 between zeros. They said only, so that's wrong. It's decreasing on the interval minus infinity minus 3. So between minus 3 and minus 3. And 0 plus infinity? No. Right? It's only increasing between minus 50 and minus 3. It's decreasing on the interval minus 50 minus 3. Yes. It's increasing on the interval minus infinity minus 3. No. So our only answers are 1 and 4. 1, 4. Type. 25 comes in the computer. Anything you see G1, G2, it's computer question. Okay. Y equal f of x equal 8x over x squared minus 64. What are my asymptotes? My asymptotes, always, let's start with vertical asymptotes. Denominator equals 0. So x squared minus 64 equals 0. So x is equal to plus minus 8. So I have two asymptotes, plus 8 and minus 8. So these are both correct, 1 and 2. They're both vertical asymptotes. How about horizontal asymptote? Check if there's oblique. There's no oblique because the power down is greater than the one up. For oblique to happen, the power up should be greater than the one down. Let's see. Horizontal asymptote. Take x as infinity. You're going to have infinity, 8 infinity over infinity square. So you're going to cancel this with this. 8 divided by infinity is 0. So y equals 0 is the horizontal asymptote. So 4. 1, 2, 4 will be my answer. Also, you can use the rule if the power up is less than the power down. That means y equals 0 is your asymptote. Let's see. So 1, how many? 1, 2, 4. 1, 2, 4. Okay. Do I continue with tops? Okay, I'll just leave that to a different recording. Thank you so much for watching. Wow, good luck.